Actually, reactions of heat now we are going to consider, and here we will see the reaction condition, how much heat involved, either it is releasing or this is absorbed by the system. See, thermochemistry, here heat may be represented in form of delta E, Q or H. These may be in this case minus exothermic, maybe reaction positive, that is addition of heat plus and endothermic. So in one line you can see all those reactions in case of which energy evolved during the reaction termed as exothermic. Heat liberation is there, exothermic, endothermic. During the reaction process of reaction, you will find that heat absorbed by the system, this is termed as endothermic. Now, let's see heat of reaction, in this case, equivalent of hydrogen 1 reactant, that is reactant 1, equivalent of reactant 2, both get reacts, and this one they forms product. So this is heat of reaction. Fixed amount of reactants just reacts and gives products. Means you can consider here that 1 mole of hydrogen get reacts with 1 mole of chloride, forms hydrogen chloride gas, heat liberates here, that is minus 24, means this is exothermic reaction, heat liberation showing, and this is at 25 degree centigrade. Means when the fixed amount of reactant get reacts, forms a product, heat is termed as heat of reaction. In formation of hydrogen chloride gas, liberation of 44 kilocalorie heat takes place at temperature 25 degree centigrade. Now second is heat of combustion. Reactant get combust, forms products. In this case, the heat evolved is termed as heat of combustion. Okay, let's consider unit gram, unit mole of this going to react and forming CO2 and 2H2O. Here gas methane combust by here oxygen you will find gaseous state, combustion takes place, gives CO2 carbon dioxide gas and liquid form of this water. Heat liberation is minus 212.8. Now heat of formation. Heat of reaction and heat of formation, always don't be confused. Heat of reaction focus on reactants, definite amount of reactant. Now you will find 1 gram, or you should consider this all in the molar form. For the formation of 1 mole of CO2, you will see the what reactants just involved into this, and they are just giving this one. Formation of carbon dioxide takes place and heat evolves, that is 94 kilocalorie. This is also at 25 degree centigrade. This is 25 degree centigrade. Next, heat of neutralization. Equivalent of HCl get reacts with equivalent of base. HCl reacts with NaOH. This reaction is known as neutralization reaction. During this, heat evolved is termed as heat of neutralization, that is at 25 degree centigrade. So this is in aqueous form, aqueous form, aqueous form. In case of heat of formation, again see this one, this is solid state, this is solid state graphite, this is gas state, and this is gas. One time going to revise this. Thermochemistry, you will find the reactions, these are either exothermic or endothermic. Heat evolves during the process of reaction, exothermic, heat absorbed by the system, endothermic. Heat of formation, heat of reaction, heat of combustion, and heat of neutralization. Now you see, as the name indicates, heat of reaction. Heat of reaction means two reactants reacts and forms products. So definite volume of the hydrogen and chlorine gas is get reacted and it forms hydrogen chloride gas. Heat evolved is termed as heat of reaction. During this process of reaction, heat evolves, that is minus 44.0 kilocalorie at 25 degree centigrade. Second is heat of combustion. Fixed amount of reactant get combusted in presence of air, excess of air from CO2 and H2O. Heat evolves minus 212.8 at 25 degree centigrade. Now heat of formation, fixed amount of product is being formed, so it is termed as heat of formation. Heat of production, it is also termed as heat of production. So here graphite carbon get reacts with oxygen giving CO2 gaseous stage, and minus 94 kilocalorie heat is evolved actually, released, you can say, termed as heat of formation. Now heat of neutralization, definite equivalent of acid get reacted with the definite equivalent of base giving salt and water. This is water and this is no water. You should consider this kind of solution actually aqueous better. It is giving heat of neutralization, that is minus 13.7 at 25 degree centigrade. Now next head is what mechanism is being involved into this. Just we are going to see the reactions. If the reactions are taking place in one step or several steps, the heat evolved or absorbed will be always same. This was studied by law. This will show also the mechanism. Now you see in next lecture, that is, now you see in same. Now, law of thermochemistry, Lavoisier is one law and second is Hess law of constant heat summation. This is law of thermochemistry, that is Hess law of constant heat summation. Now you see, law was given by Hess. Law states what? That the amount of heat evolved, either it is just releasing by the system or absorbed, or during the process it is being absorbed in the system. In both the cases, first of all you must know that either the reaction is in single step or in the multiple steps. But in both the cases, heat will be equal. No variation in heat would be there during the chemical change of reaction. So this is constant heat summation reaction. This simply indicates in multiple steps, even if it is going on, the heat, sum heat will be equal to the total heat if it is just considered in single step. Now you see the amount of heat evolved in a process including chemical change. In the same process, either reaction completes in single step or multiple steps, heat would be same. See, in this case, this is the initial phase. You can say that A reactant convert into B. In single step, A converts into B, heat evolved is Q, capital Q. Now, this is one condition. Second condition, the same reaction, it is going to happen in different steps. A first converts into C, heat evolves Q1, C converts into D, heat evolves Q2, D converts into B. Finally, A is shifting into B. Heat evolves Q1, Q2, Q3. In this case, Q1, Q2, Q3 is equal to Q. According to law, now you see A converts into B, Q1, capital Q1. Now, this is the multiple steps. Here it is single step. A converts into C, heat evolves Q1, C into D, Q2, D into B, Q3. Now, according to law, what will happen? This is single step reaction. This is 1. And this is multiple steps. Step 1, step 2, step 3. See what will happen here? According to law, Q will be equal to Q1 plus Q2 plus Q3. This is termed as heat summation law. Heat summation law. All the sum of heat is equal to the heat in taken in single step. Example, you see, this is the example, similar example. This is one step reaction. First reaction is one step reaction. Carbon get reacts with oxygen giving CO2, heat evolves, that is exothermic reaction. If you will write it, it will delta H equal to minus 94. This is actually, this reaction is in single step. Now, second case is same reaction happened in 2 steps. First, second. C plus half O2 equal to CO plus 26 kilocalorie. And now CO plus half O2 equal to CO2 68 kilocalorie. Both sum of this is 94. Means here you will see 94 is equal to this heat form, you see 26 plus 68. This is here formation of CO2 in single step, formation of here this is CO, this is CO2. First step this is and second step this is. So overall you will see that the heat of summation Hess law, this is here available, means in case of Hess law, amount of heat evolved or absorbed will be always equal in chemical change if it is happening in even single step or multiple steps. Now we will start next head, thermodynamics related law. That may be the first law of thermodynamics we will start in upcoming lecture. Thank you, students.